All right. So this week is a fun one. It's all about making something big and using the Gerber and large production processes to make things happen. It's one of the biggest machines that we have physically. It's got the ability to make lots of cool stuff. I made that furniture piece sort of as a showcase to see what you could do with the machine. And so we're going to try and cover the big ticket items just to cover the bases with what we have and how we can make stuff with it. Also, I don't know if I posted these exact slides into the chat, but I'll post the folder and these also, so you can get a look at them. But we're going to cover these different topics. We're going to talk about three axis CNC, which is what it is. All of our CNC machines are 3-axis machines, and that doesn't necessarily make sense until you talk about what a 5-axis machine is. Then there's roughing and finishing, so we'll talk about that process if you've got a complicated thing you want to make. 2.5D designs, which is probably my favorite of stuff to make. And then along with that, dog bones and end mills, like how do you actually make something on the Gerber. Up downs, like up feed, down feed, your speeds and feeds for bits, vCarve, Fusion 360, and some of those different tools that you can use to make stuff. And then we'll talk about Gerber safety for the last little bit. So first up, 3-axis CNC designs. 3-axis CNC motion is like the 3-dimensional space that you might have in a video game. Playing old school Mario Brothers was 2-dimensional. You could go up, down, and you could run right, left. But 3-axis is Super Mario 64, where you can run up, down, left, right, forward, back, and you can go in all sorts of different directions. They're always referred to as X, Y, and Z in CNC machining. And so it's what lets you have this like hemispherical shape. You can have movements that are up and down and then also sideways. You can see this bit here sort of moving around. It's a little hard because of the perspective, but it's moving left, right, back, forth, and then up and down a little bit. And those are the types of machines that we have. Our spindles are always locked in a vertical position, and 5-axis is this, where you can see this red spindle that's able to rotate around and go to crazy dimensions. So 5-axis machines can usually rotate either the spindle or the workpiece in strange orientations, and that's how you get pieces like what they're showing there. We do not have an A and they're, instead of X, Y, and Z, because it's the end of the alphabet, they loop back around to A and B. We do not have an A or a B. It would be really cool if one day we extended the Gerber and added a rotational axis, or had a temporary plop it down and now you've got a rotational axis, because then you're talking about CNC lathe work, which is really cool. But we just don't have that. If you watch Frank Horwath on YouTube, he has a CNC with a 4th axis, so he can do it, which is Frank Makes, I think, is the name of the YouTube channel. But he has a CNC machine with those things. He makes a lot of bowls where he'll like spin the bowl or do interesting cut stuff. One of the neat things about these 3-axis machines is they can make just about any geometry that you can imagine, as long as there's not an undercut. But they can be really slow. So a lot of the things I do, I try and make sure that the designs fit within the constraints of the bits that I want to use. This like hemispherical thing, just looking at it, you can see it's sort of got steps on it, and then it's doing something to turn it gray. That's a round-nosed bit, which is really cool because it's able to cut sort of a circle. And as long as you can get tangent, as long as you have those 2 spheres tangent to each other, you can get really precise gentle curves that are very sweeping, and it works great. The problem is that if you have very detail-oriented things and you won't have a tiny little bit that's going to cut it, it can take a very, very long time. So time is a major factor with the CNC for how long this is going to work. And that's the one like sneaky gotcha that's going to come up. But basically, we're going to talk about how you leverage the 3-axis designs for what we're doing. So if you wanted to build something that was like a fun 3-dimensional model, this is what a lot of people will do with 3-dimensional CNC. They want to make things that you couldn't make on your own with like hand tools very easily. And so for me, that is that drain pan that you all saw for the Composites Week. And so this was, I CNC machined it, and this is the designs for that. The red is what I actually designed in Fusion 360. And then I glued up a block of 2x4s, so cheap lumber. They were all just cut, so they had all the round bits cut off, and then glued them into a block. And then I did a surfacing pass, so I got a nice level front where the machine knew where that was. And then a roughing tool path is something that you can do to remove a lot of the material. And it will, you can see all this crazy tool path stuff, but it will leave it with these steps, like the stepped pyramid sort of deal. And what that's doing is it's taking away most of the material with this big beefy bit, so that when I go down to a more detailed bit, a smaller one that's going to make more delicate cuts, it's not removing all of that material, right? I get the width of the chunky bit for all of the roughing tool path. And from there, you can then do a finishing path that you can see it like just goes over in a buttery smooth sort of way across the surface. So a finishing tool path is going to look like this, where you're just taking off all those little peaks that are left over, trying to knock off those tips so that you get what you want at the end of the day. Not every thing you're going to make will require a roughing and a finishing tool path, but if you want to build a complicated geometry, like you could totally, if you're super into it, you could carve an eagle into a block of wood with the Gerber, no problem. But that would definitely be something that you want to do a roughing tool path from, and then a finishing tool path. The roughing tool path, you'd use a big 1/2-inch bit, remove most of the material that way, and then get a little 1/8-inch ball nose and get all the tiny details of the eagle, so it's identifiable. In terms of time for a roughing and a finishing, usually a roughing can be a lot faster than a finishing because you want to go really slow on the finishing, even though this is a lot more linear inches, right? You're moving a lot faster, the bit's a lot larger, but you're just trying to clear things away so that you've got a clear spot for the finishing to happen. And there's tons of complexity just to go into that. These are all designed with Fusion 360, and you can design these in vCarve also. And I should pull up vCarve just to see it. Also, there's an entire vCarve class, which let me pull this into here. Inside of vCarve, if I wanted to create a file, and I'm going to actually be doing this, so I'll make a width and 96. So those are my two things, 0.7 inches, we're going to go with that, and 0 to the machine bed. Here's just a thing. Inside of vCarve, I'll hit this little thing to lock it. There are 3D roughing tool paths and 3D finishing tool paths that are baked into that software. So you can, it's like ready to help you do that. All I need to do is import some sort of a shape, and I should have put one on my desktop, but I can import a 3D model. And if I had a 3D model on the desktop, I'd probably do in here, funnel. That's a weird little 3D model to have, but there's a 3D model. You can rotate these around lots of different ways, but I could take something like that and cut it out. I'm going to go get another one in a minute. We can look at others, but that's a good, hit cancel and get rid of that. But this will let you do roughing and finishing. 2.5D designs are a really cool way to make stuff. This is my favorite way to do things, and you've seen lots of examples. The Wacom tablet stand is the most recent example that I've got, but I've also built all of these other things at different times. And so they all come, 2.5D construction is a funny name that really is talking about things that are built out of 2D sheets, and like you're just cutting through the thickness or not, and then you're assembling those pieces. So it's 2-dimensional cuts where your 3-axis, your Z motion is really just like how deep are you cutting, which is different than cutting that sphere, where really each little step is a factor. And so this is mostly just taking and cutting out shapes. All of these I have 3D models for, and so I should pull up Fusion also. But this was a single sheet of plywood table for a classroom. This is a little storage cabinet that took about 1.5 sheets of plywood. This is the Wacom tablet that was 1 sheet. This is laser cut, so it's a lot smaller. It's a little thing. You don't need any dog bones or any of the tolerances. Laser cut 2.5D is actually really pleasant and a great place to practice.
What is that?
It's a little tempeh incubator. It's an old 3D printer bed inside of a box. It just like has a few buttons on the front here, you press the buttons and say, I'd like you to stay 80 degrees for 4 days, please. And it does. It's a very niche use. And so if anybody wants to make tempeh, make their own, you're welcome to try it.
It's a good DIY, like bread proofing device, right? Like
absolutely.
Many things that need to be kept at a temperature for many days, and
100%.
You could incubate eggs in there probably too, right?
I'm sure I could do lots of things with that, but I'm just gonna. It's so far not seen a lot of love. It totally works. Carolyn is suspicious of it, not setting a fire. So I've let it run in my house before we lived together for days on end, just as a test. But it hasn't seen use since we've lived together, which has been a while.
What is the thing on the right? Is it a launch ramp for a car?
It's a launch ramp. So one of the Science Olympiad events is gravity vehicle, and so this is a ramp cut out of 3 sheets of plywood. The inner one is colored brown, but these are 2 like normal sheets like you'd expect. The one in the middle, I actually lied to Fusion 360 and called that a piece of sheet metal.
So I could flatten and bend it.
So I could bend it. Yeah, I got a bending design, and that's going to come up in a minute. But you can, with the CNC, it's very easy to make very repetitive cuts that would be terrible to do by hand.
Yeah.
And so for that particular piece, we had a piece of plywood that we just cut a bunch of slots in, and it becomes just bendy enough that we could get that angle to work. And so in the competition that year, everybody had ramps that would like sort of flop around as the cars went down, and ours was all solid plywood. So yeah, so it worked like a charm. We even this was the early version that the girl is using here. We ended up putting things with wheels on it, so you flip it over and you could roll it around on casters because it was easy to do. And then the stool is fun. We could totally, if you want to make a stool, that's a really fun, quick starter project for practicing all this. And I have video tutorials you can follow to do that. Oh, here's actually that design for the ramp. So there it is. You can see that this is flat pattern. This is a piece of sheet metal, and according to Fusion 360. And I just had to sort of finesse the bending rules for how it worked. And then these lines, I exported and put into vCarve and used those lines as cut lines. So it would cut every one of those black and blue lines to make a structural weakness in the material so that it could be bent just slightly. It just barely made that curve, but that was enough. And so it works out great. But in the same way that laser kerf bending is a lot of fun, this is a lot of fun on a big scale. It totally works. You can go all the way through, and you also don't have to. But typically your bits, I mean, I try and make all of my cuts with a 1/4 inch bit because I just don't want to think about it. And so it restricts like your radius and how much you can do. But Ada last year used a 1/16 inch bit to do that, and she could get much nicer curves. It was way more elegant. Mine are always sort of like sledgehammery design choices. But you can get really nice detail if you wanted to have that work well. Another thing that's super useful if you're entering this space and going to make something big is that there's a lot of cost to that. So making something small first is really helpful. If you've digitally designed something, and to make the Gerber run, you've totally digitally designed something, making the small model totally has value. So doing this little one just to make sure that I didn't lose it is really, really helpful. I would always encourage you to do that. Here's another one. This was back in times of yore when plywood wasn't so expensive. This would have taken 3 sheets of plywood and would have been great. Back when plywood was $35 in Ohio. That's not true anymore. But making little models of things like that can be really helpful. And ultimately, it's just a math problem. This is where your high school algebra 1 skills come in. This is a similar triangles math problem, where you take the thickness of the plywood and the thickness of whatever you're making the model of, and you just do a fractions relationship, and you can come up with what percent smaller, like what percent size it is, and it'll cut like a dream. And so for this material was 0.7 inches for the table, and then the little wood that I used was 3 millimeters. So I put them both into millimeters, I think, did the scaling. I think it was like 13% the size. So you put in 13% into Inkscape with the design, it shrinks it right down and it works like a charm. And then you can just cut it on the laser.
That's clever. So you didn't scale it in Fusion.
No.
You just exported it as it was designed in Fusion and did the scaling in Inkscape.
Yep, where you can just say 13%, done. It solves.
I was thinking about how you,
yeah,
like, man, that must have been like kind of annoying to like
oh,
come up with a whole second design that was smaller.
It,
that's very clever.
It's a really good trick. Yeah,
oh, man.
Yeah, it's so fast and worth it that like there's scrap mat board over there.
Yeah.
If I'm gonna invest an entire sheet of plywood, I would never not do it.
Or like a $6 piece of
the
super thin plywood we have back there.
Yep, it's always worth it. Whatever it is that you're gonna do, you should totally make a.
So if you design dog bones, even that will scale down.
It all scales. Yeah, because you're like when I export that and I can pull it up and actually look at it.
You wouldn't really need to export the dog bones into the laser cutter, but you could, and it wouldn't make a difference.
Yeah, it doesn't matter at all. I can pull it up in here, look directly at so let's find the stand. Here's the thing. And so inside of the stand, it's going to have me export just one file. And so I think I had to change a couple of things. I made it through with a couple of different cuts for this stand to work. But once it loads, and it'll load eventually, inside the manufacturing model, and then let's center this back onto here. There's this model, and then I did a couple of sketches, and I think it was this one. The DXF export was maybe the last one that I did, or maybe, fences make good neighbors. I needed to change the fences size. So those were the fences that I cut for the real thing, but this was my like exported value. So I can, if I go into the manufacturing models and do some editing, so edit manufacturing model, now I'm able to take this DXF export. I just name the sketch that, right click, save as DXF, and then here it is saved right onto my desktop. And I'm just going to say in class. And then we can open up Inkscape. And from there, you just import it and do the scaling right there. All the dog bones, all the whatever, it's going to be super tiny. That's not a problem for the laser. It doesn't have any dimensional limitations. So it's all totally fine. You just import it and scale it right down and it works like a charm. Is it opening on the wrong screen? It is. Always on the wrong screen. Okay. Yep. So here's this file, import, and then it should just be in class. And a DXF is a native import to any of these vector design softwares. So it shouldn't be a problem at all. It might have given me, it's giving me prompts on the other screen. And so it's going to say, do you want to scale manually, automatic, scaling to size A4, like for paper, or read from file? I just do read from file and it's going to take it directly in. And it's going to be huge, right? So in here, it's my entire document is probably like the size of a sheet of paper. But I think it's frozen trying to import. Oh, there we go. There's the design. You can see it's much bigger than the sheet of paper. But if I have all of that and I just change this to percentage and I've done the math and I know that it's 13%, done. It's scaled it to, it's gone. I don't know where it is now. Oh, it scaled it in just one dimension. Yep. Yep. Yeah. 13%, just like that. And now it fits easily onto, I think that's a sheet of paper, right? So it's going to fit onto the other things. And I can go in and just do the cuts. I think when I did the test, I changed made it MakeHaven logo to a different color so I could just engrave it. Same for this like inside of the drawer. But it's that easy. All of the dog bones are still there and they're very small and it's totally fine. It's not a problem whatsoever. There's a few places where this got touched up. Like here's a missing dog bone right there. And so that's an interesting point. We're going to talk about dog bones in a minute. That would be a problem when I go to register the things. So I had to fixed that before I actually made the piece. But there's dog bones that you can have in all sorts of different orientations. But it's good to be able to come in and test your parts and pieces all this way. So back to this. So that's the trick for a scaled model. Just scale it down by the percentage size that you need to be at. And it's only by the thickness that you have to worry about. None of the other dimensions matter, which is kind of a magical math trick. So it works really nicely. So those dog bones that we're talking about, they are important features for when you're doing this sort of a thing. Dog bone is something that you need on a CNC design just because we use a round cutting tool instead of a square cutting tool. And so you could manually go through, you could not include them if you wanted, and manually go through and file every corner square. Because most of the time when you have these things that fit together, you want to have sort of a square joint or some sort of an angle joint. And the bit can only get so close to a corner. So the method I use is I just overcut it like that, or like you saw in here. And they can be a number of ways. Like here, I'm overcutting. You don't need to overcut an exterior corner. It's just interior corners like this one. And so in this like T-shaped thing, I did dog bones in like that. Or if you've got a square relief that's cut away, you need to have them on the inside of those squares. And then you can choose whether you want them to be on the sides or the front and the back. I went with front and back for these because they'd be covered by the piece of wood. And then I went with the sides for the front one sort of arbitrarily because I thought I didn't want them sticking forward. I don't know. It doesn't matter too much. It's on the underside of the top of the desk. Nobody's going to ever see it. But those dog bones need to be, and here on the teeth, they might make the most sense because instead of having just a square in and that way, it's better for me to overcut and then it fits right when it comes off the machine. So adding dog bones like that is something, I've heard that there's extensions that do this really nicely. I find it's a pretty easy Zen mode, put on a TV show and just like click, click, click and add them into all the places where they belong. So I have control over it. I just draw in circles. And so that's really all it is. And so you want to do that. A dog bone is a really important feature. And so there's that, but then there's also tolerance. So dog bones come in after I do a tolerance pass. So a dog bone are the little circle parts, but then there's also what we were highlighting was the 0.2 and the 0.4. These are places where I add in a little extra space. Like the plywood for that bench was 0.7 inches thick. And it was but I see it be anywhere from 0.69 to 0.71. And so it wasn't perfect 0.7. And that's perfectly normal for a sheet of plywood. You expect it to have some variability in thickness. Even the acrylic out there, that's really nice stuff, it's going to have some variation in its thickness. So you need to add in a little extra buffer for that. In this, if we go back to design and take a look at the design space for this guy, I've got, it's a part of my workflow for how I do the design work. Like in here, I tend to section off different parts of it. Like I'll do top surface, bottom surface, simple wall, this like fake computer. I just sort of go through all the different features that it takes to build this. There's a key drawer, and then I get to here and I start to add in all of my like somewhere in here. It's before the hardware probably. Yeah, here's this one where I just go through and I add in all the tolerances and all the dog bones. So if I go in and I edit, let's pick a different one. If I edit that sketch, I can come around and take a look. There's lots of things that I could hide and go away with, but basically I just add a rectangle with an offset so that it's a little bit bigger, and then I draw my circles onto that so that I can extrude those dog bones and the extra space onto either side and make those disappear. I also will typically do, because I'm a big fan of parametric design, my favorite strategy, maybe I'll finish the sketch and it'll freak out on me, is to do, come on, you can do a fusion, is to set in parameters. So I'll define like the size of those circles with a definition first. So if I were to change the bit, I could in theory type in a number and hopefully it doesn't all break, right? Those are, you know, I've gotten better at it not all breaking, but it's just part of the game, right? If I was a professional doing exclusively this, I'm sure I'd be good at it after a little while. But it's just part of the game. They break sometimes when you change a parameter. And I don't know why it's not opening the parameters window. Maybe it's
I had bad luck trying to use parameters in Fusion. I think I was doing it incorrectly.
yeah, I think let's go to a simpler design. Maybe just something easier. So we'll close this. Don't save any of that. And we'll just like make
touch it.
yeah, we're just gonna do like if we draw on a rectangle, and so that rectangle wouldn't be a problem. And here's, let's say, a thing that we want to cut. And if we finish that sketch and extrude, no problem. Easy peasy. There's our material. If I wanted to do the tolerances and dog bones, I would do it on a sketch right on here. And there's an offset tool, is this one. I leave it in the surface. It's also with the key O, and I'll usually go this way, and I'm just gonna plop that down so that it's offset like that. It's really nice and easy.
So if you're working with, say, like 3/4 inch plywood, and you want a 1 inch long slot, you'd then offset by your amount of tolerance. So like maybe like
100th,
100th,
200th,
okay.
like very little.
Small.
Yeah, it's and we have, for the two of you who are physically here, in the back, I have like the tests that I ran on the cut.
Okay.
So you can see I started off with one that was like no tolerance whatsoever, just to see how that fit. And you can get them together, but like it takes some banging.
It's not gonna come apart.
And that's for two tabs that are this far apart. Once you're talking about a big piece that's got some bow in it just because it's a piece of wood.
And there's 8 tabs.
Yeah, and there's 8 tabs. Like, you're not getting it in. And then I did the other side with that model. I also guessed at 0.3 for my tolerance, and that was 0.03, which is 300ths, and that was way too much. It was floppy and loose. And so then I did another 2 tests at 0.1 and 0.01 and 0.02. And those 0.01 turned out to be the winner. Because you want it to go together, just like you would in fine woodworking. You want it to go together fairly easily, but sort of take some wiggling to come apart. So that's the game. If it would let me open parameters, and I don't know why maybe I need to finish the sketch. Parameters. It's weird that it's not letting me open it. Maybe modify, maybe I get to it through here. Change parameters. Well, it makes a list. I've even got it all in the thing. But I would usually assign a keyword to that, like tall, T-O-L is what I usually do. It's 3 easy keystrokes and it's the right size. That way, if I decide I want to change the tolerance, all of them change together in the model. Same deal for the end mill and the dog bones. The dog bone size is decided by the end mill size. And so usually I'll use the keyword bit, B-I-T, because I find it's quick to type. It's just easy to type in there. And then if I decide all of a sudden, well, my 1/4 inch bit broke, I want to change it to an 1/8 inch bit, I could make that change fairly easily by just typing in a new number for bit. And most of the time it opens. And so you can make those sorts of changes. But you do that. Let me go back in and finish that sketch. So this would be sketches I'll usually name. And it's having a time and a half.
Maybe you need to save, shut down, and open it up.
I probably do. I probably need to, let's just do a test. Live test. And close and reopen the thing. Live test just like this. Okay. So we open the sketch and let's edit the sketch. And what I would usually do is just say, do this. And then often I would type in bit, but I don't have a bit in here. And so I could just do 0.25 and I'll put it on. When you drop a shape run into another shape, it'll assume that you want them to be coincident. It's blue, so it's not super fixed in shape. So I'll also say I want it to be tangent to that line. It snaps it in black, so it's fixed in place. Those are all good Fusion 360 practices. and you can go around doing that for all of the different spots. C for circle, do that again, start it right on the thing, the center's black. I'm playing the same game, right? Do this to that, make it tangent, and then if I want to, I could even say this should be equal to that one. So if I want to just define in one spot what they all are, those are all like good practices to use. But then, you know, if I wanted to extrude, what I would do is really just remove the things that are the dog bones and the tolerance. Select. Usually you have to pick one in order for it to go smoothly. So there's those. Those are the 5 things that I want to have cut. And I'll just cut all the way blind. It's fine. Just a weird blind cut. But that would give me 2 dog bones on the top and a full tolerance on the sides. Way bigger than you'd need, but that's the general idea. I do the entire design first and then go back and do that to the design once I have it where I like.
So does that end up as a second sketch superimposed over the first one?
Yeah, and so that's where that's how this works. If we go back to the tablet stand, I did everything. Like if I come back to that point in my, usually I've gotten to a pattern where like I want to do the entire design first, then I'll go back and I'll add in any hardware that like I really want to see because I need to see it. And then I'll do all my tolerances and dog bones inside of the design space. And in here, I think it's to one of these. There's all my tolerance and dog bones. So I can roll my design to there. And it basically looks the same.
Got it.
Right, no major changes. This is all the structural stuff. If I were to zoom in on any one of these or like make this, you know, there's no dog bones on those rectangles. It's all the main shapes and pieces and things, but none of those features. They're a late addition. There's even some reason to argue that you should only add them inside the manufacturing space. Like there's the design and the manufacturer. I don't know. I kind of want them in the design. But that's like where do you prefer to have your oven mitts stored? It's that kind of a question rather than where does it need to be. So that's an interesting piece, but you'll definitely want to think about it if you're building big things on the Gerber, because plywood is not as uniform as you'd like it to be. And basically the cheaper it is, the more that's true. Baltic birch is pretty consistent, but it's not perfect. But like sheathing that you'd buy for like $30-$40 a sheet, it's whatever. Like they don't even know how thick it is at Home Depot or Lowe's. They just spray paint it with 1, 2, 3, 4, or 5 stripes for like approximate thickness. And then they put up a fake fraction to sort of guesstimate how thick it is. So mostly you're just going to need to be conscious of those things, but you can master it. And OpenDesk is really the place that's done a fantastic job with designers who, and it allegedly and I think we've talked about them before, but they allegedly have all of these designs available for download, where you can download these things and then you can make them in your makerspace. I've never seen them. They're always down for maintenance. So I've never seen them be downloadable. And I think even still, they really only wanted to target Europe, where there's a lot more fab labs where you could really make an order. But they have some really cool inspirational pieces. So if you wanted to go in and take a look at like, how would I even go about building a desk like this? They've got cool designs you can look at. There's all sorts of cool stuff to go along with it. Let's check just for fun. But in here, there's some neat options. There's also, I've got a friend, and I should have added the photos into the slideshow. I've got friends with a 1.5-year-old, and there's some little kid furniture that's also CNC cut and assembled that way, because it can be assembled toolless. Whoa. That's it. So their website's like down. Yeah, that's a server error, a 500 error. So that's
Never mind.
never mind. We're not doing that. Okay.
I did try to look at that when we were talking about CNC stuff the last time
Mhm.
in OpenDesk, and I had the same experience. And it was like lots of presented information, but nothing that I could actually hit.
Yeah, no actionables. And I think that increasingly showing up on the spaces like Thingiverse, it was all just 3D printer to start with, and now it's 3D printer and laser pretty easily, and I think CNC designs are showing up, but it's going to be rare. but there's, if you follow Hackaday or a few different places that like post maker news, there's often good designs that come through that are pretty neat. And then the stool that we have up there is fun. There's a lot of cool examples that you can build. But here's important details about end mills, and we've talked about these a little bit, but I like to just remind you, feeds are how fast you're going, and speeds are how fast it's spinning. In the metalworking space, those are really important to absolutely get correct. Like I have lost bits on chunks of aluminum, and I can imagine losing them on chunks of steel if your speeds and feeds aren't tuned just right. Because in the case of metal, you're scraping away the metal as the bit moves forward. Too fast and your bit gets dull, too slow and your bit gets dull. And then with aluminum, it'll heat up and like turn gummy and stick to the bit. Like there's a lot of things that can go wrong, but wood is delightfully polite. The main thing with cutting wood is that you'll want to look at getting the right amount. These are great videos to watch, by the way. This is the machinist like metalworking idea of what this is. Here's the Jonathan Katz-Moses video that's really good on watching and understanding these. And then here's another person going through the math of it. But just reiterating this downcut, upcut dynamic is real important. An upcut bit is going to be better. What it does is it cuts and moves all the material away from the workpiece. It's cutting since all of our bits are oriented down on these machines, it's moving the material up and away. A downcut bit presses down into the material. It gives you a really nice top edge, but it's also compacting everything into the bottom of the cut. And so that's fine, but upcuts leave like a frizzy edge at the top, which is a little problematic, but you can sand it off very easily. It's a problem if you have a super thin veneer on a piece of plywood, then an upcut bit is a problem. And so CNCing cheap plywood is bad with an upcut bit. A downcut bit is pretty generous when you're doing plywood work, but it's really bad if you're drilling holes, because when you drill the hole, it's also pushing the sawdust down into the hole. And some of it will leave, but not as much as you'd want. And you'll get little like smoldering, not smoldering, but like little darkened, burnt up spots at the bottom of those holes. So it's thinking about that dynamic is important. If you want to know the short answer, I always have a 1/4 inch downcut bit in my bag. That's like, if you can't possibly process which one you want to do, I have a 1/4 inch downcut spiral bit that I carry with me all the time. An upcut bit is totally fine. I find that the tearing is something that I'm not good at managing well, but some people are really good at that. And so if you wanted to get better at the nuance of this, if you decide you love this, you will understand them both. The good starter answer is a downcut bit.
That's your preferred bit is a 1/4 inch cutting size and a 1/4 inch shaft size.
The one that I use, that's a good question. My bit that I own is a 1/4 inch diameter.
Yeah.
And the cutting edge is like about 1 1/4 inches long.
Okay.
And so, or 1 inch or so long, maybe 3/4 of an inch long. And so the like spirally part is about 1 inch long.
Got it.
It's a 1/4 inch wide, and the spiral is the cutting part.
Got it.
It's a 1/4 inch in diameter. It's a 1/4 inch shank.
Yeah.
So when it grabs it, it's at a 1/4 inch piece there, and it's all just one big piece.
And you can use that 1/4 inch shank bit in both the Shapoko and
the Gerber. And so I just have the one bit, and I keep it. I like bought it myself for like $20, and I carry it around because I know it's sharp, and I know it's the one I want.
Corey, the ones that they sell in the supply room,
Yeah.
I didn't say that it says whether they're upcut or downcut, and I'm not able yet to tell. Do you know what they are?
The ones that they sell, I'm pretty sure are labeled, and I'm pretty sure they're upcut.
Oh, well, if they're labeled, they don't say upcut or downcut. They have some other labeling on them.
The big thing that I do is I twist it, and I have no idea why. If you twist it, if you're holding it, pretending you're the robot, but also like it's a screwdriver, it's going to twist in that direction. And so
it's clockwise. Is it always clockwise?
Yeah, it's always clockwise. So if you spin it clockwise for the downcut bit, it will be obvious. If you consider it like an airplane wing, it would be pushing the chips down. And for the upcut bit, it would be pushing it the other way. And so
Okay.
it maybe, yeah. So that's the game. It's making me look at those bits that I have on screen, and I think they're actually mirror images. If you look at the Jonathan Katz-Moses one, these down, let me open this up and not play the video too much because it's his content. I want to let, you know, he can get his views from all of us. But and then an ad. There's CNC machining. I always get these ads. But in here, let's get a photo of these bits. So over here, these are labeled upcut, these are labeled upcut, and these are labeled downcut. So the downcut spins in this way and the upcut spins in that way. And so when you spin, yeah, I'm thinking about it. When you spin it clockwise, it should feel like it's going to spin up or down, but
All
you're
right.
totally doing it clockwise like a drill.
All right, and now I guess I see that there are letters on there that I didn't know what they meant. Okay, it does say up and down. All right.
Yeah. Another thing that's an option is this compression bit, and it's worth looking at these. These are really cool bits. They're relatively, you know, these flat cut bits, these are older technology. They have carbide or flattened hardened steel cutting edges, and they work great. If you watch this video, see that they're fine, but the spiral bits are much better because instead of giving like a smack to the piece of wood when it makes the cut, it's sort of shearing in a more of a, like a scissor would do when you have a spiral. And so that was a later advancement, sort of like how flathead screws were the first thing, and then Phillips came later, and then Torx is after that. Flat cutting edges were the first router bits, then you had spirals, which worked great, and then they proliferated up and down. And then these compression bits are even later additions, because you can see that they do one thing, and then they've got this funny business at the bottom. And that's because they are upcut for the first like little bit, and usually that's specified, but usually it's about a diameter's worth of upcut, and then the rest is downcut, so that if you plunge it into the material far enough for your first cut, the fringe problem that I talked about that an upcut bit has will be solved if you meet certain qualifications. They're really nice. They're also fairly complicated to use, and they're often expensive, although I've seen cheaper ones start to exist. And I'm not good at using them. I like to make sure, well, when I do these cuts, I try and go for depth no more than the bit's thickness, and compression bits are always sort of dancing on the edge of that, where you need to go just past the thickness. Like you need to start your cut at this depth in the bit in order for the compression bit to really be working the way that it's supposed to. But that's another important feature, is that for these bits, for speeds and feeds, there's some squishiness to it, but a big thing is that you want to do, oh, let's get back to the thing. You want to be cutting about as deep as the tool is wide. And so when you're choosing your, let's go back over to vCarve, and we'll go to File, Import, Vectors, and we can go to Desktop and Class. Okay, so we're going to import these vectors. A couple of things that we need to do. Oh, maybe I'll make a new one just to get the settings reset. 48 by 90, there we go. And I want to do File, Import the vectors for this. Here's this tool. A handful of things that you might want to do. This is if you have open vectors, like I have some that aren't connected. You do this inside of vCarve to join your vectors, just so you have closed shapes. It works out nicely. Mine imported with a rectangle around, so I'm going to just delete that away. And then if I come into here and click on this, I can set up my tool paths for what's going. So in here, I've got a whole bunch of options for what to do with this tool path. Here's my downcut end mill 1/4 inch. It's because this is on my computer. It knows what it's doing. Cut depth is 0.7 was the most recent thing I designed. And I'm going to edit this tool. Inside of the tool, there's a bunch of options. Like the diameter is 1/4 inch. I have 2 flutes on my cutting mill. The pass depth is 0.1. I could probably be more aggressive and go 0.25 without any concern. Most tools should be able to cut the depth of their width without a problem. And then the step over is how much, if you're clearing an area, how much will it move to the side? Sort of like when you're mowing the lawn, you want 100% step over. You don't want to mow over the part that you've already cut. But for end mills, it's sort of in the middle. You don't want to have 100% step over like on a lawnmower. You want a 50%, 40-50% step over, because part of it is doing the good cutting action. And then if you don't let it have a release, it doesn't have anywhere to put the chips. So it's about a 50% step over. 40, 50, 60 is all in the right category for here. The speeds and feeds, you can get way into the weeds for how much you want to do here. Typically, what I'll think about, this is the max speed on the Gerber, is 1600 RPM. You could do 1200 RPM and you'll see my chip load is changing. I just want to keep my chip load to be about the right amount. And there's a big table that Lior has over by the bank of computers. But it's calculating chip load based on the spinning speed, the RPM, and then the feed rate of 110 inches per minute for the Gerber is a little on the slow side. I could probably cut with a 1/4 inch end mill almost like 250 inches a minute, which is tearing up the thing. That's going fast. And so they can move really, really quickly. The Gerber is much faster. It's double the speed of the Shipoko. And that Shipoko that we have is easily double the speed of the one that was there before it. But the Gerber is bigger and faster, is really the name of the game. So if we do this, we hit OK. We call it tool number 10. Let's come back over here to toolpaths, pin this. We can make some different changes. Like I can edit my passes. Inside of here, I could say I want to have 3. This is cutting down this depth in my material each time. You could do a last pass thickness of like 0.02 if you really wanted to have a nice like finishing pass to hit the bottom. And number of passes, if you want to change this, you can make very conservative cuts. It depends on the material, right? So plywood is going to be fine. It's not going to be a problem. And so I think I would go with 3 or 4. I'd probably do 4 without that last little pass. For this, I think that's what I did when I actually cut it out. Then there's a whole bunch, and you can set separate passes here. You can do it there. Inside of vCarve, you can specify if you want to cut on lines, outside lines, inside lines. Tabs are there. That's a good, we're going to get to tabs in a second, but tabs will hold the piece in place. Like this would cut it free from the wood. You don't want it to be totally free because the last thing that's going to happen is it's right up against a high-speed spinning bit, and then it could get thrown, which is a safety problem, but usually it doesn't go very far because I've had that happen. The bigger problem is that it often wrecks the piece, right? Or maybe it breaks the bit. Usually the piece gets wrecked in wood. And so that's what you really don't want to have happen. I mean, the safety concern is the #1 priority, but I've rarely seen that, and I've seen a few crashes. Several crashes, really. Back over to here. So we've been playing with vCarve. vCarve is perfect for 2.5D. It's my favorite way to design 2.5D toolpaths, actually. It works really nicely. I know that there's a class to do it, to learn vCarve. It's got its own quirks, but so does Fusion 360. Like neither of them are, I would say it's 6 of one, half dozen of the other. If you want to learn one, you can learn either one. The vCarve licenses that we have here, you're going to download and install like a demo version for your computer, and you can get everything set up. But what makes it the Makerspace edition is that only with the ones in the space can you download G-code. So you can save your file for vCarve, and then you just open your file for vCarve here, and then you save your G-code and put it on the Gerber, which is actually great. Like you can futz around with it at home, get all the things just right, and then bring it in, move it through the bit bucket, and then open it on the computers.
So your workflow was to design that entire process, add in all the dog bones and the tolerances, and then export it to vCarve and set up all the tool paths
In vCarve.
in vCarve.
Yes.
And
So
then bring that file from vCarve here on our computer and then export the G code to the Gerber.
yep, you got it.
Okay,
Yes.
cool.
Yeah, and
Steps.
it's a lot of steps. We're going to go over other ways you can do it. So vCarve that worked for me in this case because I like 3D modeling. So 3D modeling was just like a thing that I did over a couple of evenings to design that piece of furniture. Then I exported the DXF. What slowed me down is I wanted to learn the right way to export the DXF. You can also just like, okay, and let's pull Fusion 360 back up and we'll open up this design. Any sketch at all, you can export as the DXF. So if I open this up and there's sketches, this sketch right here made it MakeHaven. I right click that, save as DXF. So there's a DXF that I could open in, and you can open this directly in vCarve if you want. You can open it in Inkscape if you want to move them around. There's software called deepnest.io if you want to have them be nested to optimize your material use. That's now baked into Fusion 360 also.
Yeah.
But any DXF you want to get, you can do. You saw on the one I exported was a specific one in the manufacturer space, but I used to do it without even opening the manufacturer space.
Yeah.
I would just do this. And then if we go back to here, open up the live test, I would just make it like I get to this point. I have 2 sketches already that aren't named. That's bad practice. I should name them. And then I just make a 3rd sketch. When you make a sketch on a surface, when it's got the geometry, it collects all the geometry of the surface. So at this point, I could finish that sketch and then right click, save it as a DXF, and it's got all those lines. And we can do simple test and then come back into vCarve. We'll close and do a new one. Let's do another new. No, I don't want that. And we'll just import that vector again. So import, once it, hit OK. File, import vectors, and simple test, just like that. So there's the simple test down there. And that's it, right? So that's the whole thing. It's definitely, there's some weirdness to this, but I like that toolpath because of my preference for 3D design. There's lots of other ways that you could do it. You could design it completely inside of Fusion 360. If you think vCarve is terrible, but you love Fusion 360 already, you can do everything in one place in Fusion. It's incredible what you can make happen. Like the tablet stand here, I designed, then used the manufacturer space to lay it all out. And it did the nesting for me. Fusion did. I didn't have to lay those out, which is great. I did the catch basin, a 3D model with 3D geometry and then 3D toolpaths all inside of Fusion. I did not design that in vCarve at all. I took the G code straight out of Fusion 360. And then this is a sheet metal part that you can also design in Fusion 360 because it's got so many ridiculous options. So you can really get to many different types of making with Fusion. It's why it's absolutely my favorite 3D design software, that it's got a free version for makers and that you can do all of these different things. So it's a lot, like there's a lot to unpack to get to those steps. I don't want to say that it's easy by any stretch, but it has the ability to do all these things if you keep investing in learning this one software. And so there's tons that you can do. Then there's the slicer for Fusion stuff. This is another one that's great. I will say it is out of date. It's not officially supported. I have the installer file. You're welcome to have it. It's also, you can find it online still.
I think I Googled it.
Yeah,
you got it. You
Google it and you find it. Because they wanted to roll it into Fusion instead of it being, it was an external device first. It was just Slicer. Then they made it Slicer for Fusion as an add-in inside of Fusion. And then they took it out of that because I think they wanted to make it a paid service. But because it made it out into the world as a free standalone thing, it's still a free standalone.
It does say like using Windows XP, like this is not a supported product.
Yeah, it's pretty clear that they don't want you to use it, but they also don't want to pull it away because they would lose a lot of friends. And so it's out there. But like, this is what's cool about it. Here I designed a bench in just like a mushy, like, oh, it's a fun shape for a bench. And then I imported that and it sliced it up for me. And then here, and not only does it slice it up for you, here's the 3 sheets that it would need to cut it in that layout. And if you look really closely, and I had set it all up right, and I don't think I did, it would even put in tolerances and dog bones for you. Like, it does all of that. And here's like a slightly different version of the same bench design, where like you can even tilt those slats, you can make them all, there's lots of knobs that you can turn, but it takes all of the trickiness of making that design. Much of it is taken away. Like in the case of this head, it's a 3D model of a scanned head, I'm sure, that somebody used as the basis. Or this bench, it would have just been the simple like enclosing, like the envelope shape. And then the slicer for fusion takes that envelope shape and turns it into all of these different pieces that it takes to make it. You can decide how many of these you want to have, how spaced out or tight together they are. There's tons of different versions for how you would do this, and different knobs and dials to turn here on the left. And it can be lots and lots of fun. So one of the things that I'm talking about doing with Julia maybe is making like a 3D MakeHaven robot, and we would probably build it out of foam and then cover it in. She's got some crazy like movie set, looks like stone putty stuff that she knows about. And so we would take a 3D model of the robot and then make it out of a series of stack slices and cut it out of foam. So it's super lightweight and coat it in the stuff to make it look like stone. And then it can be a fun bird bath. You know, so you've got you're making it out of materials instead of building it out of wood or something else that's heavy or expensive. You buy the 2-inch foam at a big box store and cut that on the Gerber, which cuts like a dream, by the way. It doesn't melt. It turns into terrible sawdust. It sticks everywhere.
There's that vacuum.
The vacuum's good. It's the static that's bad. We run a grounding wire up through that vacuum on the Gerber, because if it doesn't have a place to ground that static, you can have a real problem.
Yeah. It makes sense.
Yeah. So there's a grounding wire in it, but it works really well. And machining that 2-inch thick foam is really a fun way to build stuff. I had lots of kids that would build hovercrafts and stuff out of that because it's super lightweight. You can cut it to exactly the shape you want. I did a 3D relief of a mountain in that, and then did it. My very first composite material, I took GPS data and used a CNC to cut. It was Mount Baker, which is right near Mount St. Helens, or Mount Adams maybe. And so now I forget. But I took that GPS data and cut it with a roughing toolpath and a finishing toolpath, and then I had the geometry of that mountain. The composite didn't turn out well, but like you could do all of that in foam, and you can cut it really fast. You can remove a lot of material, and you get the good geometry if you want to use it for a mold for something. It can work really nicely because it's basically solid. It's not like a open foam. It's a very tight foam. So we've got all these different processes. Let's say you want to make something big. That's the goal. Hopefully, there's lots of ways to do that. If you have a rough idea, you can design it a whole number of ways. I probably would go through this 3D design toolpath over here, and then eventually get to something like the DXF. You could also just straight up design it in Inkscape if you wanted to. You do not need to do 3D design, but you'd have to be very thoughtful about how they're going to fit together. And then once you have all that, you need some sort of a way to come up with the manufacturing. So this is a CAD process, computer aided design in either category. And then this is a CAM, computer aided machining. So you're going to have to use something like vCarve to cut these out. This is actually making these stools is delightful. The legs nest really well. If you need to make a class set of them, hypothetically, it goes pretty quick. And so they come right out of the sheet of plywood, and you can just pop them together and put them together for an impromptu presentation outside, and then take them apart and shove them in a closet when you don't need them. It works really well. Doing something simple for your first thing is definitely a good way to get started. But you could also shoot for the moon if you really feel like you need to. But definitely go for a design path that makes the most sense to you. There's plenty of things to learn along the way. If 3D modeling is still a mystery, then doing the 2D design can be a good way to go. If you want to just like get sort of squishy with the 3D model and then use slicer for fusion, that's a nice easy option also, where it handles all the like nuts and bolts of making it. Because really the new skill is going to be this CAM to production piece for what's new this week. And so finding a way to shortcut your way through the design could perhaps be a good choice if you needed to. But that said, like making something big is multiple parts. There's something about a physically large project that makes it different and hard. And then there's the advanced CNC skills. And I would say those are two different parts that make something big. Because just like maneuvering large material, getting it here, you know, like if you need a sheet of plywood and we didn't have a few sheets in the back to sell, then you'd have to figure out, well, I'm going to buy it, and then I need to get a truck, and then I need to get it here, and then I need to get it back to where it's going. And like, there's a lot of different layers to making something that's big and transported. Everybody is a fully capable adult, so I'm sure you've dealt with those sorts of struggles before. But it's definitely something that makes it a level up project, even if you're building basically the same thing that you could have done on the Shipoko. Just like the logistics of it becomes a lot harder. And so those are sort of the two goals. And which brings us to the last little bit. We're talking about the Gerber, and so we want to see what we're up to. Basically, there's a few safety rules with the Gerber. There's a whole bunch of machines that we have, and they have various levels of danger. The Gerber is certainly not the most dangerous of the machines, but it is one that has a cutting tool that moves automatically. So that brings in something. If I were to rank machines in just the wood shop that are dangerous, probably the Gerber is like number 3 or 4. Like it's not like the lathe, I think, is probably number 1 because the big spinning mass. Then the router table probably, because you're not that far from it when you're using it. And the table saw is probably table saw, router table, lathe, like those are the top 3 in my mind, no problem. The Gerber is another step down. But you know, if things go terrible, there's a story of some poor woman in France who leaned too close with hair not tied back. And we don't need to go any further with that. Like that's, yep, the lathe would totally do it too. So like there's a lot of things to think about. So what you should know is that the Gerber has red motion interrupts. There's big red stop buttons in 3 locations around the machine. Those will cut, it will turn off the ability for it to move. Those are really important to know what they are. There's a software one and 3 hard buttons. One's on the computer and one on either side of the moving the moving thing. Then if it's moving automatically, and it's important to be very careful with how we say this. If the Gerber is moving automatically, stay outside the barriers. Some parts of setting it up, you're going to need to manually be in charge of moving it. And in those cases, only the person who's driving should be the one that's there, because you don't want like a surprise, right? Like in order to make it fit, we don't have a touch off switch that works with it right now that's integrated fully into the software. So the Shipoko, when you're operating the Shipoko, it'll move a bit over to a button and press the button to measure the tool's like length. The Gerber does not have that presently. So it's got some clunkiness that in the badging you're going to learn, where you have to manually say like, this is where the end of the tool is, and orient to where the piece of the workpiece is. And so some of that you're going to need to be manually controlling it. But I would say once it's automatically moving, all those barriers have to be up and you need to be outside the barriers. That's what keeps it able to be sort of on the edge of a buddy tool. They were talking about making a laser cut line, sort of like at a museum. If you get too close, the alarm goes off. But I think that these are perfectly adequate for safety. Once it's running on its own, if it's running any G code at all, you should not be touching it. You should not reach in and grab something. If it's going to crash into something, you're not diving in to save it. It's going to crash into it. Touch the interrupt. That's the best you can do. And then that's it. That said, I've run machines like this very safely with less than these safety protocols. These are going to keep you safe if you follow these guidelines. So make sure that you're doing that and you'll be good. Another thing is that don't walk away from a powered up machine. It's not like it's going to jump to life, but it's not clear that it's powered. So you can totally pause it, but you don't want to, ideally, pausing it is totally fine. but you wouldn't want to like pause and go get lunch, right? Yeah, you could pause the machine, and ideally you'd say to somebody like, hey, I'm gonna leave this on. Can you just stay with the machine so people know that it's on and like that it could be running?
You could come over and poke something
and it could turn on. Yeah, like you want to have somebody who's there for that, but because you don't want to walk away and use the bathroom. Because it could, like in theory, somebody could walk over and say, "Oh, what's this?" And then it could just go. There's a whole bunch of things. You should use the motion interrupt whenever you're changing out the tool, the like tool that's in the piece, which is a pneumatic held tool. If you're using a wrench to change tools, if you're cleaning up the work area, if you're adjusting the dust shoe height, any of those things, you should stop the machine. And then if you're setting the Z height, and you should not be, you can independently spin the axle even when it's not running G code. Don't spin the axle when setting your Z height. Feels obvious, but you could do the opposite of that. So be careful. Setting the Z height is probably the moment when you need a buddy in the room, but otherwise it's not, it's like, it's labeled buddy tool, and I think it's not a buddy tool if all the barriers are up and you're out of the way. But it's like a halfway to a buddy tool. When you're setting the Z height, there should be a buddy, because that's the one moment where you're close to the machine while it's moving. It's not automatic, but it's moving and you're near it. So you should have a human nearby. Self-homing on position limits, or manually jogging it around, like driving it, or if it's running G code, those are when you're out of the barrier. Anytime that it's running automatically outside the barrier.
So you're on the computer console doing stuff.
Yep. Or like Ruby's got those real long cuts that she'll run. She comes in and like brings her laptop and just like does whatever. When I've had real long cuts, I've sat there and played a video game. Like it doesn't, you just need to be there to sort of babysit, wear the earmuffs because it's loud, and stay outside the barriers, and you'll be totally fine. It's a lot of fun to run. It's totally worth it with all these safety things. I am not worried for safety on this machine. Like I said, it's definitely below the big three, the lathe, the router table, and the table saw. It's safer than those, but because it moves on its own, it's got a different sort of set of concerns. The table saw isn't going to jump at you, whereas this could. And so that's the thing that you need to be careful of. But I want to say that to be clear, I don't want you to be scared either. It's just got a different set of concerns. So what to do this week? Get badged on the Gerber, cut a circle and a square, if nothing else. Like if you just wanted to do that, be a perfectly reasonable test. If you have some Shipoko design and you wanted to just learn the like weirdness of the Gerber, just recreate your Shipoko thing on the Gerber. If you're not really trying for something big, you just want to get the experience, you could build something with 2.5D design, or you could recreate something from OpenDesk if you really wanted to go for it.
Yeah.
But you can't even open the website. So all of those are reasonable things. And I think to put it in a larger context, we just started our like last section of the course. So we're going to be, this week is make something big. Next week is molding. The week after that is casting, all with Julia playing in the mix. And then after that is a wildcard week. And so you'll have some time during that wildcard week to do whatever. And in my mind, like molding and casting are pretty buttoned up. So the make something big is probably realistically going to be over the next 4-ish weeks. So getting in and get badged gets you the ability to actually come in and do stuff. So that's what I would recommend. Lior and I are going to be here on Thursday to do a badging. We can work out the exact time. But my gut says like 6:30.
Let me know.
Yeah, and so we'll just do it then, so we can go through and make sure everybody gets the badge. Everybody has done Shipoko stuff, so you're good to go with Gerber. And from there, it's just good to get in and get playing. But that's it. That's the whole game. The design stuff, like building these crazy big things, takes a lot of design. These sorts of things here is a big design game. And so designing your own for any of these items is lots of fun, but it takes a lot of work. Like in order to, this was actually student designed from some of my high school kids. but I was working with those kids for 4 years straight. So like, it's a long time coming, but it's an achievable goal. And some of them are easier. Like this table is only 2 different types of parts. It's the tabletop and then all of the legs. Oh, it's 3. Each of the legs is only 2 unique parts, right? So it's only a couple of designs. I just filled out the 3D model for the look of it. And this, I mean, this is just 2 parts, right? These are identical on the opposite sides. So you can make them as interesting or as complicated as you want. If we head back over to my Fusion 360, we've got, let's see, inside of foundations, we've got that. And I think we've got, but there's lots of other examples. So you can, my Science Olympiad team from Ohio did a lot of 2.5D design for the things that they built. And so that's, I would say, separate from really the Gerber, but it's a really useful skill to learn. Like here's gravity vehicle. It was a little, this is the ramp design. And then here's a car. This car was designed in February 2020, just before the whole thing. But this is all to be laser cut out of cardboard. There's not a good cardboard color in Fusion, so we just use a wood. Laser cut cardboard and then a few pieces of wood up here in the front. This is the pieces of plywood. So it's, you know, it takes some time to get better at that. This is the Sounds of Music, the instruments. Here's the cello thing that they made, the cello guitar. And this is more 2.5D. Let's see if and lots has changed in how I design things. We turn off the top skin. There's these different layers. These are all, you can see there's some, like to make this shape, it would eat up a lot of wood if each one of these was like full body shape. And so we cut them and then gave them enough overlap that we could sort of glue them back together. So it depends on how you're building things, but this is a fun way to make stuff. Like you can get rid of that and that one. And then we split it differently for this. We did like a little thing there. So you could make these would all sort of nestle together nicer by cutting them up. And so there's lots of different ways that you can make things that are relatively big. Let's see, we've got that. And then where's other designs? The steam bus is where those carts were. Here's these carts that are a lot of the same thing. This one was designed with lots of hardware in mind.
Like this curvy profile.
The curvy door. And then we were the Wildcats, so paw prints. If you'd have 3 of these in a row, you'd get little paw prints between them. They were meant to be on a bus, so like those were also access points to latches that would hold it in place, some pegs for an immovable shelf. All those are different things. And like the way that these designed are now, I would design them very differently. But you know, you can put away the doors, and then here's all of the dog bone stuff, right? There's dog bones there. They're more visible in this orientation, but it doesn't really matter. Some people hate that aesthetic. There's entire articles on just how to do your dog bones. I like that. Those are T-bone style usually is the way that they're called because they kind of make a T shape. There's dog bones where they're sort of like diagonally off the edge. There's French style, and I don't know.
How inconsistent can I make my dog bone?
Yeah.
Drive everyone insane.
Yeah. There's
3 corners.
Yeah, it's kind of fun to do. There's no reason for them to be one way or the other. French, you can like, all it needs to do is make the smallest part of the corner big enough that the bit can be in there. Yeah. And so you can put, you can make the circle have a point be on the edge of the circle and make it just a slight little depression out on either side. And it can be super subtle. Yeah. I just don't have the patience to get that right.
Yeah.
And so any way that you want to do it is totally valid. So you just have fun playing with that and designing. It's usually, here's another strategy that's really fun. If you're building things, is how are you going to actually join them? And so you can see sort of, there's the problem, right? You cut this piece of wood and it's got a straight edge. You need the dog bone for that. I call this trap nut construction, where like there's where I'd put a bolt inside of a thing. So a bolt comes in from the front, and here's a nut right there that you thread the nut in. And by getting that nut is sort of held in place, that opening is just big enough for the opposite flats on the nut. So the wood itself is acting like a wrench. And then this surface is being pressed on by the nut so that it's held in tightly. But that nut is not rounded, and so I overcut it with dog bones on this side to make it work. Probably could have gotten away without doing that, but this sort of there's lots of different options for how you do it. Let's see if I have one with hardware. Yeah, here's a design with hardware in it, and so you can sort of see the bolts in there, see how the trap nut works. Yeah, so there's like the bolt going in, and then the nut would be in here, and it would just go right up against that surface.
So you pop the nut in first, then
Yep.
you shove the bolt in and start screwing.
Yeah, you pop the nut in, then you put the two pieces of wood together, put the nut in sort of from the side, and then crank down the bolt. And it's a very strong connection, but that you can easily disassemble.
But why don't you show it with that in there?
Because then I would have to design that and make it fit. I knew that it was going, and I knew that this was
easy to design the screw.
Yeah.
The bolts. Right?
Oh, you can import them. So like you can import parts from MasterCar, but just getting them to line up right was going to be terrible.
So you keep going, but harder to represent.
Yeah, it was just harder to draw. Plus, I knew it was going to be viewed from this angle, so it didn't matter. So I could just like have the bolt fronts, and it was fine. It was fine. These are the handles that you needed to get to, like an early version from that paw print. So all of those. Oh, and here's one up against the wall. We were going to mount them. These were carts to go on a bus with Fab Lab equipment in it. It's a real niche project, but then we were trying to figure out how to mount them to the wall. So, trying to figure out some logistics for all that.
So it was a dog food project?
It was a dog fooding project. Yeah, we were using the Fab Lab to build carts for the Fab Lab, which is really common actually, but also you can go in a deep, deep well of how nerdy do you want to get. So it's lots of fun. There's all sorts of different, this was our first version with a big circular opening. A kid definitely designed this. But like look at that. He got all the trap nut and the dog bones are there, big circular opening. It was lots of fun. It took adding in some team members to realize that the circle was bad. And that kid's great. He's going to be a fantastic engineer. But that's the game. You can do all sorts of different projects with this. There's tons of opportunity, but the design is one half and the Gerber is the other half. Getting the Gerber badge would be more than enough for what we're up to. Yeah, but like if you found something that was cool, or if you wanted to, if you wanted to do something easy, I think inside of the foundations folder, I've got the flat pack stool, and there's a video of like follow the instructions. It'll show you how to design this, and then I just recently turned it into a manufacturing model. But this will, you can see sort of there's a slot on the bottom, a slot on the top. Those will fit, and then the seat that just fits over this ridge works like a charm. It tests all these ideas just enough to like make sure that you've had to struggle with dog bones, had to struggle with tolerances, and you get a stool at the end. So it's fun. And if you do this design, you can make the small model. Like all of these things can be tested with something as simple as just a stool like this, or an end table, or doesn't have to be complicated. You can get a lot of experience with this by just trying out something relatively simple. The video tutorial for this is, I think, 20 minutes.
Seen it.
Yeah.
I don't remember like where we find it now. It was way back when.
I think I just posted it to the Foundations chat. So it should be there like fresh from less than 2 hours ago. So that's those I would recommend following. It's going to feel like a fast-paced fusion video, but you can pause, go slow, put me at quarter speed if you want, which will sound weird, but is okay. Any of those options that work for you are all good. If you wanted to do manufacture, you can do all your tool paths in here, although I would still probably do them in Fusion. Hey, how'd it go? That's good.
Gonna be badged pretty soon.
That's exciting. Cool. Well, we just talked our way through the whole Gerber thing. So you just got the badge that we've been chatting about, and then you get to watch the video and see what we were up to. But now let me stop the share. It's time for the best part, which is show and tell. I'm very excited to hear what you've all been up to, what what sort of things have been going on. And we can, let me do, yeah, we did the cut over to here. And so there's 2 people that are online and 3 people that are in the room. And it'd be great to hear from any and all of you about what you've been up to. So anybody want to go first?
I can do it, but I need to share my screen.
Change. Okay, you should be able to share now.
Yeah, so I'm just grinding on this chest of drawers. And up at the top is a display panel area where the idea is that the little panels will be part of the chest, but also could pop out, be replaced, could serve themselves as little display things. So I started with a photograph of a fishing shack that's near where I live. It's actually the town symbol of Guilford, although it's more kind of almost in Madison. With the picture, put it into vectors with Inkscape, took a pretty nice piece of wood and resawed it with a bandsaw to get it to a size that was suitable. Laser cut the vector file onto this and then cut it out with a scroll saw, and then use the Shapeoko to put a pocket into this thing, and then sanded the edges to get it to fit better, and there it is.
Oh, that's lovely. Yeah, I really like that. The recess for it, it's such a nice, it really translated into a vector nicely. Like it's clearly exactly what it was.
Yeah, you can tell what it is. Yeah, I thought it worked pretty well. It actually looks better. This is a close-up, and it looks a little bit better. It looks like it fits better than it really does in real life. But I want to be able to switch these too. I want to be able to take the whole thing out, and I also want to be able to put a new panel in. You know,
Yeah,
with a different thing.
Yeah, that's really cool. Huh. And that, you know, you touched on so many different processes in getting ready for that. That's a lot that happened in that little tiny panel.
Yeah, it took a weird number of tools and materials to get it done.
Yeah, no, that's cool. You did a lot, and that's a great week's work. Awesome, great job, Norm. Cool. Let's see, Arvia, if you're around, or there's the 3 people in the room. Whoever, Arvia, you turn on mic or camera, will be good. But in the meantime, maybe Vincent's got a thing sitting on his.
I can jump in.
Yeah, go for
it. So last week I talked about my kind of like pile of Arduino devices that I'm trying to adapt to do something that's outside of the scope of the class, but my mail keeps getting stolen.
Oh no!
So I keep ordering stuff and it keeps getting stolen from my house because the Amazon guy kind of like hucks the package on the street. So I had a bunch of stuff sent to my friend's house, and by the time I got it, I kind of didn't really have time to like mess around with it. But I did mess around with the micro servo, the stepper motor.
There you go.
And what was the other thing? Something else that you gave me to play with. So I played with a bunch of stuff, but it wasn't what I wanted to be playing with. But I'm really excited about the stuff that we talked about today.
Yeah.
That little toolbox that I made, I feel like that whole design process is gonna like really lend itself to doing something out of a big sheet of plywood. And I think I'm gonna try to make like almost like an extra countertop for my kitchen out of one sheet of plywood if I can. Yeah, it probably won't be very big. It'll be more like a little sideboard almost, but
it's
I
totally
design my own and make it.
Yeah,
it'll take me a couple weeks to get there, but
that's totally fine. And like it's completely reasonable to say like, hey, let's go halvesies on a sheet of plywood if you think you can do something like that.
Yeah.
And you've got some people that want to collaborate on that.
Yeah.
But you're exactly right. That toolbox is spot on what you're trying for.
Right. So pretty cool.
Yeah.
And hopefully I'll have an Arduino thing to show off next week.
Yeah. There's a member who gets stuff delivered here sometimes.
I've been thinking about that.
I don't know. Just talk to JR. I don't
So
know.
the post office has a key to my building, but the other delivery services do not. So it is just left outside, and it's like really frustrating.
room?
No, it's like it's like a 6 apartment building. It's like the USPS guy has a key, you know.
Yeah. But Amazon.
Good.
I know, but that defeats the whole purpose.
Yeah. Yeah.
So I had stuff sent to my friends. Sometimes I get it, sometimes I don't. And I did it like the heat and humidity sensor and the SD card reader.
Oh
I
yeah.
just never got. So
Yeah.
it's like, but
Yeah.
whatever.
Hopefully you get a nice solution to your package problem. Yeah, it's rough.
Eventually.
Yeah, it'll happen. Huh. All right. Whoa. Let's see. RV, if you're around, and it's okay if you're still transitioning or still eating. That's what I would probably be doing. And then either of you guys want to share? All right.
I have to model it.
Yeah, it sounds great. Oh, I'm excited to see how this came out. So it's all one piece.
Yeah, well.
Yeah,
Yes and no.
it's all the way around.
Wow. Looks nice.
That is really nice.
That's-
Yeah. Oh, and it crosses in the back. That's really
It
nice.
says this is a thing, it's called a Japanese apron, a Japanese pinafore.
Oh,
Yeah.
And yeah, it's good, you don't have to tie it.
that
This is laser etched?
Yeah. So let me tell you all my learning experience.
sure. Yeah, I want
I'm
to
not
know.
even getting into the sewing. So you saw that I posted on the laser chat that as it started, it was doing beautifully, and then all of a sudden it started etching double,
Oh yeah,
and then it went back to not.
that's so weird.
Or I moved on to so I did it in 3 separate
Sections.
sections. So this section, once that was a problem, I said we got to solve this, and so we put it out there and everything. And it really turns out, thank God, the only problem was the lens was dirty or it was not screwed in tight enough. We did both. We wiped it, screwed it in tight, and then everything was perfect. So
Great.
even though we were taught when we were badged, you got to take the lens out, wipe it, put it back in, and screw it in right. Nobody ever does that.
Nobody ever does it.
You should.
Okay. All right.
This is what happened.
Sure.
And I had done my test swatch the day before and it was perfect. So in the course of one day,
Yeah.
somebody using it or whatever, or
Yeah.
So then by the time I was done, I was very confident. Okay, I get it. I understand how to do this. So then I came back the next day. I designed the scraps, decided I was going to etch them too.
Yeah.
And so here's the thing. Remember how when we brought stuff into Inkscape for my cutting board and how for the test one, how
yeah.
it came in too small, we didn't realize it. And so we cut a tiny one.
Oh,
Say,
sure. Yeah.
but that doesn't happen often, right? Well, it happened luckily I brought in spare fabric with me. I did the first strap and it did the design too small for this big piece. Oh, geez, it didn't come in 100%. So here I am with this. So I have to calculate up, okay, my graphic is what I have here.
Yep.
So I enlarged it in Inkscape to what I thought was right, and it worked. So then I cut a new strap, and I have 2 straps.
There you go.
Then for sewing, I could never coordinate with the minimal amount of time that people had for batching on the machines.
Interesting.
I had this Sunday at between 7 and 10 p.m. I said, by then I want to be done with the thing.
Yes.
So I just said, okay, I'm gonna have to use my sewing machine,
Yeah.
and so it does fine, but it doesn't, there's a lot of layers here by the time you turn it over.
Oh yeah.
Like especially where things join here. So the needle doesn't always want to get through all of that. So
Sure.
I have to like really work out what it is, how it's going to get,
Yeah.
get anyway. So that's the deal.
You could even probably, like, now that it's all together, you can probably even do decorative stitches. Like, I think, on jeans, I gotta imagine that half the stitches are kind of decorative. And so
Yeah,
maybe
yeah.
do, like, if you wanted to.
I'm not.
Yeah, nope.
But hey, here's the other interesting thing. I had to, for the first, this my machine, I've had since I'm like in middle school.
That's
It
great.
was a while ago.
Yeah.
And only this weekend did I read the instruction manual. I still have it.
That's great.
And because I had to learn things I didn't know in terms of controlling the tension, because this is different fabric, it acts a different way.
Mhm.
I had to there's areas like up here where they join, take it off, you know, it frays, this
Yeah.
fabric frays, so I wanted to kind of zigzag the edges.
Mhm.
It's called overlock, and a traditional sewing machine doesn't have an overlock feature. That's a serger feature,
Oh, yeah.
and the serger's not around right now.
Yeah, it just came back like
Okay.
yesterday.
Was it broken and they had it fixed?
There was something that needed sharpened.
The blade, I remember the blade was
Okay.
missing or something.
Yeah. And so whatever it was, they sent it out to get fixed, and now it's back. It just got back yesterday.
So I had to learn how to, you know, makeshift, you know, do that with a sewing machine, which I did. And here's the other thing. Always remember, when you're sewing, make sure that you're only sewing what you intend to, that nothing gets caught, right?
Oh, yeah.
So right out of the gate. And so I sewed down like that, fine, go across. By the time I come up here, it's caught. So I had to undo all those stitches, and in the process, I frayed the fabric to the point where there was a hole.
Oh, no.
So I learned how to
How-
darn.
Mm.
So I learned how the machine could darn it. So I filled it all up.
That's
So
great.
all good stuff.
Yeah, that's a ton of new skills. and it looks great.
Yeah.
So that's awesome.
Did you laser cut out the fabric as well, or you just accidentally cut it
No,
off?
I cut it.
Yeah.
All with that.
Because the three pieces, we like talked about it, right? But the three, like, in order to get the shapes, because they were big,
Yeah.
and so getting it to line up.
It
were-
would
Yeah,
be more trouble
yeah.
than it's worth, probably.
No.
Yeah.
Yeah, there's some giant lasers that you could just put in a bunch of fabric, but
Yeah.
not ours. So
There's a fashion designer downtown who has a machine that can cut fabric for you. It's like the size of the Gerber. It's
So-
pretty.
Yeah, I like him.
yeah, that would be fun. Where does it cut it with a knife or with a laser?
I believe a knife. I'm not totally sure. I didn't look that closely.
Yeah.
So he'll literally cut it for you, your own,
Maybe if I hired him, I don't know, but
he
I
does it for himself.
yeah, like to sell. I'm not sure exactly what he does.
Oh, he designs clothing. You can buy it.
That's true.
That'd be cool. Yeah. It'd be neat to have a drag knife attachment to put onto the Gerber. So you could just like lay things down. You definitely need to put like a backing cutting board,
Like the vinyl cutter, right?
like the vinyl cutter. But it's actually not impossible. Actually, that's not impossible to imagine. Like just get one of those big cutting mats like we have for the sewing cutting table,
Yeah.
lay it down on the Gerber, get a drag knife attachment to put in as a tool. It would honestly probably work. Now I'm wondering how to make one. That'd be fun. So yeah, there's lots of cool things to do. Arbia, we're gonna ask again if you're around. Oh, and there's a chat thing. Maybe she's in the chat. Okay. All right, cool. No worries. And then we've got Vincent, which you've got a board in your lap.
Yes. I decided that I was going to start the cutting board. It's going to be a butcher block, and I underestimated how heavy this thing was going to be. Yeah, so it's maple and walnut,
Where'd you get the wood?
Parkerville Wood Products in Manchester.
Okay.
MakeHaven members get a discount, so like you can find it on the website.
Cool.
I jointed and planed all the boards. I just didn't get around to like ripping them and gluing them up, just because I was like, all right, the last edge glue up didn't turn out so well. So I'm just going to see a facilitator and say, here's what I'm thinking about doing. Is there anything that can go wrong between point A and point B?
Yeah.
And I was going to do it on Saturday, ran out of time. Then I decided, well, there's a class going on. I guess if I have any questions, I'll ask Ben, because there weren't many facilitators last week. So I was like, all right, well, this is the first time I could see one. And turned out well so far. I'm going to cut it up and make it into a checkerboard pattern. So this is like halfway through.
Cool. Yeah, and it looks great. I'm excited to see the checkerboard pattern in the end.
Why is it, were you testing out oil on it?
Oh yeah, I was testing out some mineral oil on it just so I could like show off. Here's what it's gonna look like at the end.
Yeah,
Here's
that's
the color it's gonna be.
yeah, totally reasonable. That'll be fun. I think that you're really gonna enjoy the look of that sort of a end grain cutting board, and then the way that a knife just glides into it will be really nice.
Cool. Never had one before, so looking forward to it.
Yeah,
Then you can choose how thick you want it to be, right?
It's gonna be just under 2 inches thick.
yeah. So it'll be a chunky, like not a huge board, but real thick.
Mhm.
Which ought to be good. And then you can come back and like sand it again if you ever wanna, if you get sick of what the surface looks like. We have the drum sander, so you just,
I was thinking about doing that with mine that I made in September.
yeah.
Yesterday, I was like, I gotta bring this thing in and resurface it, but it would take 5 seconds.
It won't be long. You just like run it through the drum sander. It's gonna be a tiny little amount.
Yeah.
Yeah, that's great. The jump into mind, like for the glue up for that, the most frustrating thing is probably gonna be getting it to be lined up. All your checker boxes, making sure that it doesn't look like offset steps. And so different people have different strategies. One that people really like is to put salt in with the glue,
Right.
like sprinkle a little salt because it gives it like a tread so that it can't move sideways. I just like hit it with a hammer on the side, like a mallet, a rubber mallet, until it's about right. Once it's half in clamp pressure. Also I'd cut it with a crosscut sled for your next cuts because it's pretty big. The crosscut sled will support it from both sides as you do the cut. Works well.
Yeah.
But yeah, you're totally on the path to having a nice end grain cutting board.
Awesome.
Yeah.
Thanks. Pretty soon I'm going to be circling back to a metal shop and electronics. I also picked up a bunch of electronics last week. I drove like 3 hours, got home at like 11 something PM on Friday night. Picked up a Raspberry Pi Nano, Pico, a bunch of random sensors like flex sensing resistors, stuff like that.
Cool.
Where did you go to get that stuff?
Micro Center,
Micro Center.
Yonkers, New York.
And they had it in stock. They had Pi stuff in stock, or
Once I showed up, they were like, "Oh, we're out of stock. All we've got left are nanos and picos."
okay.
But when I checked on the website, like the day or two before, there were some in stock,
Yeah.
and there were a bunch of nanos in stock.
Yeah.
I guess they're in stock as long as you reserve them ahead of time.
Got it.
I saw Iris posted on Slack. Someone made like a website that scrapes like all of the places where they get posted. And that is cool, but it means that bots are also scraping all of that
Right. And buying them
and buying them as soon as they happen. Adafruit just announced that they're going to require 2-factor authentication for anyone buying a handful of items, including Raspberry Pis.
Yeah.
Because they just get bought instantly.
Yeah.
And they don't want to have it be, because so many people buy them exclusively online, they don't want it to be like the current GPU market for people buying video cards for computers.
Yeah.
Which is like, you can only buy them used after they've been used for Bitcoin mining for too long.
I also drove another 3 or so hours to get my cousin a new graphics card. My cousin from Rhode Island.
Yeah.
I got on the AMD watch list and got him a brand new card.
Oh, there you go.
And got myself a new card because the week later I got on the wait list again.
That's great. Yeah, I think I think the lesson I've learned from the last computer that I built is I will always go physically purchase a card. I'm not going to order one from the internet ever. That's the only part that you need to buy that way if you're building a computer, but you got to buy it in person. In case you're curious. Yeah. So cool. And then how was the Gerber badging that you just did?
Gerber badging went well. Because we made some push sticks together last week or the week before that, it was a lot less overwhelming. A lot of the way that you use the Gerber is similar to the Shipoko, so it felt like there wasn't too much more that I had to learn. It's more like, oh, the clamps are over here, I turn them this way and whatnot.
How many Shipoko projects did you do before you went into the Gerber badging?
2 or 3.
2 or 3. Okay.
Yeah, mostly like test projects.
Yeah.
Yeah.
Cool.
Yeah. Like You've got the most Shipoko time of anybody, Lisa.
Yeah.
And
You
So you're
think that's
just-
gonna help.
it is, you're just gonna be like, oh, this feels about right. Like
Yeah.
moving different things through. It feels a lot of the same. It's just bigger.
I'm gonna try to do a couple of logo projects. Before I try to do anything on my own on the Gerber, because I've only done 2 things on the Shipoko, and it's like, wait, how do I do this? I'm thinking about like, what do I do? How does this thing work? And so it's many steps to get it to go.
But it's also fine
Yeah.
For seeing that it has like the bits already there and it grabs what it needs and uses it.
because that's in a perfect dream world.
Oh.
That's what I want it to do. But we need to write the G code for it to make that happen. And then you need to put into your G code tool changes. So in theory, if Lior and Andrew Suzuki and I and anybody else who wants to play get time, we do have the touch off button that the Shipoko has, but the Gerber doesn't have integrated. So in a perfect world, it would be able to go get the tool, touch it off on the touch off button, and then run the tool path, and then drop it off, grab the next one, and do all of that for you. But it's a fair amount of software configuration that you have to do in addition to having physical buttons put in. And like the Gerber is great, but some of the electrical work inside the box is a bird's nest. And so that's another good summer project for me, is to like spend a few hours for a couple of days, like reorganizing in the proper setup so that it'll never come undone, so that we don't run into the problems that we've had with it before. But it's running rock solid and is perfectly happy. If Ruby can run 6-7 hour cuts,
Yeah.
you can run anything on there. It'll be fine. So yeah. So that is show and tell, and that's the thing. And I've got somebody out in the main room who wants to cut some acrylic. So I'm gonna go talk to, his name's Jacob. I'm gonna go talk to Jacob and see about cutting some big axes out of acrylic on the Gerber. And if you want to watch, I can't guarantee it's gonna happen fast, but it's gonna be what happens between now and when I go to sleep. So that's the plan. The cut should be quick, just like getting it all configured and set up. That's the game.
Oh, and if you go to the MakeHaven channel, you'll be able to see the push sticks that we made.
Oh yeah.
I saw those on there. You do those on the Gerber?
He did those on the Gerber.
Okay.
But you designed them.
Yeah,
And then we just like cranked them through vCarve and cut them right out.
Yeah.
and the laser cutter.
Yeah. But they were pretty quick to cut on the Gerber, right? 10 minutes, maybe.
Less than that, probably.
Yeah, it was quick, which is nice. It's nice that it's fast. All right. So people who are remote, we're gonna head out and do some other stuff, but it's nice to see you, and we'll hopefully see you in this space. And next week is molding and casting. So see everybody.